Okay, I'm just going to give you a little heads up on this homework. This is page 35 in the white packet for Unit 7. So this goes along with synthetic and long division, which we worked on in class. In number 1, they want you to basically figure out what the quotient would be up here in the top of this problem. So that entire thing is what you would put for A. So in other words, what number would go here, or what term would go there that you would multiply x by to get 3x cubed? If you're thinking 3x squared, that's right, because 3x squared times x is 3x cubed. Next, you want to figure out what you would multiply x by to get this 7x squared right there. And that's going to be 7x. So the rest of this comes from above that red line. If you take 7x times x, you get the 7x squared. If you take 7x times 5, you get the 35x. Then the process goes like this. You subtract this quantity. These cancel. 38x minus 35x gives you this 3x right there. So now, finally, you have to figure out what you would multiply this x by, 3, to get the 3x above the blue line. So 3 times x makes your 3x, and 3 times 5 makes your 15, for a remainder when you subtract of 0. So part A, you would have 3x squared plus 7x plus 3. In B, they're just asking you what would go here. In other words, what would you get when you take 2x squared times the 3x and times the negative 2? Now for problem 2, for some classes we didn't get to this whole concept of p of x equals d of x times q of x. They're basically just asking you to take a polynomial that they're calling p of x. P stands for polynomial. And you break it up into d of x, which would be the divisor in the long division, times q of x, and q stands for the quotient in the long division. So I'll do 2a and let you guys do 2b. For 2a, you would write it this way. The polynomial would be the original problem underneath the dividend. So we're basically taking 3x cubed plus 22x squared plus 38x plus 15, and you're figuring out what two factors multiply to produce that. Okay, so that's the polynomial p of x. The d of x is going to come from the divisor that you see out here, the x plus 5. So the x plus 5 would be the divisor on the outside. The q of x, the q stands for quotient. The q of x is going to be the answer that we had up top. So that's your 3x squared plus 7x plus 3. So you're writing out this polynomial as x plus 5 times 3x squared plus 7x plus 3. So I want you to do the same thing for B using number 1b. Next, for 3 and 4 and 5s, we're using the synthetic division process. So all they're asking you to do is figure out this missing link right there. If you remember synthetic division, you bring the 3 down, then you multiply 4 times 3 to get this a. Then the process continues. Subtract, multiply, bring it up. Sorry, I should have said add. You add, multiply, bring it up. Add, multiply, 44, and then add again. All right? So they're asking you to find the missing a, the b, the c, what would go there, and the d, what would the divisor be? When you're finished, again, they want you to write it out for all 4 of those problems. They want you to figure out what polynomial would equal what divisor times what quotient? So I'll do the first one again. For A, the negative 44 would be the constant. Let's work our way back. 7 would be the number in front of x, the coefficient. Negative 11 would be in front of x squared. And 3 would be in front of x cubed. So that would be the original polynomial. Let me clean that up a little bit. Negative 11x squared plus 7x minus 44. That would be the original polynomial. If one of the roots is 4, then that would mean that this d of x, the divisor, would be the factor x minus 4. Then the 3, 1, and 11. You basically take these three columns, which used to represent x cubed, x squared, and x, and you reduce them all by a degree. So the x cubed column is now the x squared, x, constant. So that's what's going to go in the second set of parentheses. The 3 will be in front of x squared. The 1 will be in front of x. And the 11 will be the constant on the end. One little tip here. In order to check these, what you can do, why don't you take this original polynomial and put that in y1 on your calculator. Take this factored form and put it into y2 on your calculator, and they should produce the same graph when you look at them. Finally, number 5, you need to list the possible rational roots. That involves making a list of your p's, your q's, and your p over q's. If you want to look back in your notes at page 34 for that, you can. There's also an example in the book that you could take a look at. It should be example B from section 7.8. I'll leave that one up to you to finish, and we'll talk about it in class.